testing. Are we live? I'm going to give this a second because I'm not seeing any feed here. There we go. Seeing it now. So this is an update on our solar shop project for Zambia. Okay. And where we are now is I've done these preliminary drawings of this model. I just started working on this solar panel, so that's why it's just kind of hanging out there. But I put this model together, and because you can't give engineers a model, you need to give them drawings. So I came up with this little set of drawings. There's our column grid, our foundation layout, and then just a basic overview of the perspective, the concept, and a column grid just to show the heights, the eave heights, and basic configuration. And I sent those to these companies. This is a very interesting project, and that's why I think it's worth following. I'm actually learning something as I go, which is always fun. The owner that wants to build this out of these fiberglass structural shapes. They're FRPs, fiberglass reinforced protrusions is the technical term, and they have these shapes basically just like steel shapes, and they're lighter weight. Now they don't have the same qualities as steel, structural qualities obviously, but they have their advantages. They're lightweight, easy to assemble. If you're going to ship them from America to Zambia, that's a plus. The weight factor. Also, not having to have a lot of equipment. I'm working with a fabricator, and they basically would take these shapes. This is one company, Strongwell, that we've got a quote from. And I'm not going to mention any numbers because I haven't asked the owner about that yet. So I'm trying to maintain a little privacy for him. But they have gotten back with a reasonable cost, which I was very surprised. We also sent it to this company called Bedford. They're a little more picky about the engineering, so they want someone else to do the engineering and then give them the information, but they basically make the same shapes. I haven't heard any pricing, well, rough pricing, but it was more expensive. I also sent this to this company called Liberty Protrusions, and you can see they all basically make the same product, and which is interesting to me. I haven't built anything with these before. All the buildings that I've used that are similar to this are built or steel, made out of steel shapes. Now what you'll find is these shapes are larger. If you're familiar with W shapes, which are typical steel shapes, you'll notice you'll see a W, 12 by 10 or something like that. These are going to be anywhere near a steel shape, like for a 20-foot span is going to be 12 inches wide and 12 inches tall. So, and they're a half-inch thick, the webbing on them. But I did get some preliminary cost information back from this company, and then another company that is a fabricator only is this DeFi structural fiberglass. They take the products from these other companies and basically create the prefabricated portion of the project. They take them and cut them to size and put the angle clips, the clip angles that you need to attach these together. And I haven't heard anything back from these guys. I think they're waiting on getting cost information from the manufacturer. Excuse me, I have a terrible frog in my throat this morning, probably all this year. So the gist of what I'm doing today is we're trying to nail this down. The reason I have this little graphic here about architecture is that it's just to kind of go over roughly. I'm not going to spend a lot of time on this, but architecture is a process. It's not art. Okay, a successful architect will combine art with architecture. But architecture itself is a process. Okay, and it's a long, there's a long-standing, proven process. And I just thought we would just roughly go over this. We are kind of in the schematic design phase. We're kind of melding these two, pre-design, where we're just basically getting information. We're programming the project. What we call programming means we're just gathering all the information and doing some rough assumptions. A schematic design is where we actually do this. We take those initial assumptions, that initial information that we gather from the owner, and we do rough drawings just to get ideas on paper or in CAD, okay? And that's what this is. Now, when we have some rough cost information from our schematic design, okay, we're ready to move into the design development phase. That phase is where you take all this information and start getting real, okay? And that's what I'm trying to push my customer right now into moving into more of a real phase. And by doing that, we would need information on our solar panel, our solar system. And what I have learned in the process of gathering this information is that, because there's much research needed on this type of, for me, a new system, what I have learned is that we can use, to me, the best options so far are what they call super purlins. These are, and I just got to using this drawing to draw one. These are purlins because there's so much about this project that I'm trying to keep my thoughts together here. These purlins, and I'm going to show you a little bit of a video here in a second, they allow you to have a structure and mount the solar panels also. Let's go to this one video right here. See, this is the purlin right here. Okay. And see, they can span a distance. They told me they can span 20 feet, but in our case, we would need to run the panels horizontal configuration. In other words, in solar panel terms, they are installing these panels vertically. But we would need, because of the 20-foot span, and I believe this span here is 50 feet. Maybe. You see, and this is a pretty cool system because basically what you're doing is killing two birds with one stone. You're getting a purlin, you're getting this, which is a typical shape in steel buildings. This channel, these are either in this C channel configuration or a Z shape, where this leg here is facing this way or turned the other way. This would be normally what you would install your metal roofing on, okay? But he wants to use the solar panels as kind of a roof. When I say kind of a roof, you'll have little leaks here and there, but it still provides a bit of a cover and shade under here, and you skip that cost and weight of the metal roof. Now, in my mind, these FRP purlins are going to be more. They're about $1,300 a piece, just one 20-foot purlin. These Z purlins, since they're steel, galvanized steel, they're going to be, a fraction of that. Okay, so my idea for this project is to eliminate these FRP purlins and go to the Z purlin, because it is your, otherwise this panel would have to be turned the other direction, and it becomes you would end up having to have more of these purlins just to be able to run these panels in this direction. Either direction you would have to have without a roof. So the idea here is to show this and then to go do some more pricing. And sorry about all the scrolling, but I have to navigate through all this. Okay, so what I did was I downloaded their little drawing. Now I'm not going to spend the time. If this turns out to be what we do, I'll convert this rough shape. This shape here is the actual size, but it's obviously not the actual. I don't have these little perforations. They're bends. They basically put these in here for strength. And so I'm just going to show it like this. And what I'm going to do is create a component out of this so that if he actually uses these, I'll come back and make them real. So I'm going to make this 20 feet long. I did a little bit of drawing work before I brought you in here. And so what I'm going to do is I'm going to make a component out of this, so I will be able to change it later. Let's see, I could have just made it a component. We're going to call it Super Pearl. Did I already create this as a? I thought I already created a. I guess I didn't. I thought I had already created a super purlin. We're going to find out right now. Guess I didn't. Oh, it was the solar panel I created. That's what it was. So let's do this again. 20 feet. All right. And group. Oh, I don't want that. We're gonna explode that. I don't want this in there. I'm gonna check the comments here in a second. I don't know why, but sometimes you see, I thought I had already. What is going on? Sometimes alright, that's stuck. Let's check the comments. Do we have any? It's okay. I'm making this video for the owner, and I'm doing it as a live stream because I don't have to edit the video. You know, if I record a 1 hour video, it takes 3 hours to edit it. So we are doing things efficiently on Saturday morning today. Now, before I get too excited about this, I'm going to make a layer. Do I already have a layer for purlins? Let's expand all this. Let's see, we'll just grab one. Let's call this, let's see if I have each one. I'm going to call these structure PV panels. Do I not have a layer for this? So we're going to call this, we're going to put this under structure, and we're going to call it FRP purlins. That way I can turn these off. There we go. Now I do want to, there we go. And I'm just going to start over here. Get that on that pitch. And what happens is, so is this the 15-foot one? Yeah. I think what I want to do is do this for, since they told me that 20 foot, and this may be why I'm getting confused, because I had, I'm going to explode this. I had some of these created, some of this stuff already, and you see that's why I was getting confused, because I had two different drawings. Yeah, I had one drawing with 15-foot column spans, and the other, well, expand all. So, structure, column grid, site, foundation. So we'll have to make us a FRP purlin. And grab all these. We'll put them in a group. These aren't actually accurate anyway, because I didn't know anything about these. And you can only get them 20 feet, I think. FRP purlins. We're going to turn that off. Okay. So now what I'll do is I'll go back to this other drawing. Open up the wrong one, which is okay. Save changes, yes. And we're going to take our panel and our purlin, we're going to copy it. And we're going to go back to, because I think we can get by with our 20 foot. And we're going to paste them in place. Where'd they go? Did I not say paste in place? Okay, so, oh, they're not in the same place, so now I have two of them. Any over here, probably going to be, yeah. That's bad CAD management. I should have left the building in its same spot. So how this is going to work is these solar panels will fit right there. Okay. Like that. And they have what's called a a gator clip. If we go back just for a second to here, and you go to their little, you go this gator clamp installation. And their website's slow, but you'll see here it's a clamp that this is one thing I like about this. It clamps the solar panel to the solar panel would be right here, and it clamps the solar panel down, and then you clip this whole thing to the purlin, and then you have your little wiring channel right there. Pretty neat. And so that's why I'm suggesting the system. So you would have, and I'm going to fix this, you would have, you know, and it'd be like that. So you see, you'd have slight gaps between the panels, and there's no way to really, I mean, you could caulk this, but it would be probably not practical. I mean, I'm sure you could seal it if you really wanted to, but it would, I think it would be futile. The resistance would be. Now, the other thing I need to do is I'm going to hold back from the edge because the company told me that they had not figured these like I've got them drawn, that they were butted into this. And if I can quickly find something to show you that, I will. But that's what I thought I had done. I had to put it down. There we go. Now, what they also have is, let's move this up a little bit for now. They have another purlin, super purlin, that works on the edges. And really what I want to do is, what I really wanted to do was turn this around. It's bugging me, and I know this is kind of anal, but you'll see why in a minute. And again, sorry about the scrolling, but it's hard to make everybody happy. Okay, I wanted to turn it around because this end one, they have a purlin that just works for the ends. And what I'm going to do is just fix this shape right quick. Oh, good Lord. What's happening is I'm scrolling over here in space instead of scrolling against an object. So if you're wondering why it looks like I have ADHD when I scroll. And something's wrong with that. That's supposed to be down there. Is that right? Yeah. And then this one, I need to make this purlin unique. Okay, it'll be a separate definition because it doesn't have this leg. Yeah, it only has one leg. I guess you could, if you just didn't like the idea of having two different purlins, you could use the same one. But I'm going to show it the way it's designed to be used, and then we'll go from there. I think it's a cleaner look, you know, if you use the one designed. But see, they only have these 20-foot purlins, so this would have to go from the center line so we'd have to move it to, but their flanges are 12 inches wide, so it's no big deal. We'd move it, is it 6 inches? I got 3 inches. Yeah, that's the other thing I think these flanges are going to end up being 12 inches wide. Is that still sitting on there? Yeah, good. Okay. So it would be like that. And then this one would be in the center. So what we would have, what I'm going to do is I'm going to do all the way up here. Let me see if I have any comments. Any comments? What? People are just in bed or something. This is not private, is it? No, good. I did this one time. I spent 2 hours on a live stream one time, and it was set to private. I was so mad. All right, so we're gonna copy this. I want to see what I need to do is get a rhythm here. Just want to make sure. I want to make sure I don't do that. And so what I want to do is kind of copy these up. I'll use the center of the panel so I don't have to worry about getting that wrong. So if I do this, if I go from there to here times 5, see how far that gets us. Not far, I should have said more, huh? Let's do another 4. See where that gets us. What I should have done, well, the reason I'm doing this is to see how many panels we can get on the roof with this size panel. This is an actual panel. The size of this panel is based on one of the panels that he is thinking about purchasing. And I want to show him, and that's going to work out perfect because we're not going to have we probably won't have these tails like that. So we only have that much room. As a matter of fact, I'm going to draw myself, put myself a little reference here so I'll know not to go above that. We'll just pick all these at once. And we'll put a reference on here. And we'll move that to there. Now we know we're not going to be too low. Because even though we're in this schematic design phase, yeah, that would work. You see, the whole purpose of this is that getting to this level of detail in the schematic design phase, because we want to know, we want to get the pricing more accurate at this point. So I think what I want to do now is just, let's see, up here, this one would be, let me check the super purlins right quick. Do they just have one? So if they just have this one shape, yeah, it would have to be just turned around. Yeah, so what I'll do is I'll grab it. This one needs to go away. And this would be let's spin it around. Make sure we got 180 there. So then this one would be like that. And it looks like I got a little nub there. Have to delete. Yep. So that's accurate. That's an accurate representation of what that would be, the number of panels. So it may be that, we don't need this many panels, but I'm trying to see what is possible. So then what you do is you take your panels. Let's run our purlins all the way across first. Let's so now I'm going to have 3 more. Let's see. Oh, 2 more. Yeah, 2 more runs. So I do this times 2. Is that right? Times 2. Why is that sticking up? What did I do? Let's try that again. I want this to be. I hate it when you get little bugs in your. Oh, oops. How did they get down in the? Well, at least they're all like that. I don't, except for. Let me check them right quick. Close your eyes. I have to. I don't know why. Why? I'll fix that. I think this is an issue with. Is our beam straight? Oh, look at that. Something is not. Oh, good Lord. Look at that. Look at that. That is bizarre. What's that, a 16th? So now I got to go up on this, a 16th. Yep. And this was. The whole beam is weird. Let me look at this for a second. This is not the kind of stuff you want to deal with during a live stream, but let me get this up on. That's the end plate. So I should just be able to fix the end plate. Oops. Well, I know what's wrong now. What I'm going to do is, yeah, for some reason I can't get the bottom piece to move. It's probably because, oh, I think I know. Oh, there's no. Here we go. We'll put this back. Oops. Alright, I'm going to fix that later. I know what's wrong now. I will fix that, I promise. I don't think it's worth fixing in front of you guys because it's going to be very boring. But I'll fix that. But the main reason I'm not going to spend much time on it is because I got to fix these shapes anyway. Because they cut off right here, and then the column raises up. It butts into, it's a typical steel building type detail where the column butts, the beam butts into the column, and the flanges connect. They would have clip angles on here that would bolt to the column. Right now what I'm trying to do is see how many solar panels we can get. So I'm going to put all these in line with each other. So I'm going to use the top. I'm going to use this top reference point just to make sure they all line up. Times 2. There we go. And I will go back and fix my CAD issue, because I'm going to have to redraw these beams. Now let's see how many solar panels we can get. I'm going to say 1, 2, 3, 4, 5. Could have got one more. I just didn't want to put too many. That's a lot of solar panels. We're going to count them here in a second. We can count now. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. He wanted a 40 kW system, so this may seem like a lot of panels, but so see what you'd do is, I guess you would, so that's 12, 1, 2, 6, 7, 8, 9, 10, 11, 12 times 1, 2, 3, 4, 5, 6, 7. That's 72. That's quite the number. I don't think he wants that many because these panels are like 655 watts. What is that? If you took 40,000 or 4,000 divided by 65. I'm sorry. 1, 2, 3 divided by 650. 1, 2, 3 divided by 655. That's 61. So, but what this does is, so what would that be? 1, 2, 3, 4, 5, 6 times 12 is 70. 1, 2, 3, 4, 5, 6, 7. Oh, that was 84. Yeah, so he's probably not going to want this many panels. But again, so you would either, maybe take off a row. What would you have? 1, 2, 3, 4, 5, 6, 7, 8, 10. If you just did 10 rows times, let's see how many, yeah, 10 times 6, 1, 2, 3, 4, 5, 6. So just depending on, what we would do is we would go ahead and, let me select all these just right quick. We'll group them. I know what you're saying. There's an easier way to do that, Tony. I know, but I'm looking at it right here, so I'm just going to do it this way. and we would move these. Now you could just leave them there, or you could center it. I cut and paste it back in there. So you can just decide, whether you wanted to have your roof come out to the edge like that, or you could put another row of panels. And this is, honestly, this is why you go through this. This is the rubber meeting the road, boys. And you gotta do it. You gotta spend time doing thought experiments and math experiments. And where's the center? Right there. So you could put them in the center, or you could say, no, I want to have a little shade protection all the way out on the end, because I think this is the end, the entrance. There's the containers. There they are. So you just decide, maybe they stay over to the end, and because he wants to be able to park a truck or something there. But see, let's say you have, how many purlins do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Excuse me. So 39 times, let's say these purlins are $400 a piece. That's $15,600. Okay. If you had, how many did we have? Let's turn these purlins off. Let's group these. Let's turn these containers off so I can. And we're going to still have a PV. We're going to call these Canadian panels, so I can turn them off. And then we're going to group these. Do I already have them? Those are the FRP panels, purlins. Alright, so we're going to group these. And we're going to make these. These are going to be super purlins, and I keep getting confused from my other drawing. That's why I should just have one drawing, because I think I had already made a layer for that. We'll call these super purlins. We'll turn them off. Now we'll turn on our FRP purlins. Is that right? Yeah. And how many did we have of those? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 36. So we had 36 times 1,300. $46,000. So basically, you're looking at like $16,000 versus $47,000. And that's my point about this, is that first of all, if you wanted to use these FRP purlins, that'd be fine, but you got to come up with an attachment method to put the panels. Let's turn our Canadian panels back on, and in that case, these panels would be rotated. 90 degrees, and then your purlin spacing would change. You know, I'm going to undo that because I don't like it. And and if you're worried about, he's worried about electrical strikes or lightning strikes. These super purlins are made for these carports, and these clamps clamp the panel to the purlin, and then the whole system is grounded through the purlins. So here's the thing, and here's the devil about the FRPs, is that sure they won't. I'm drawing. Sure, they're fiberglass, so they won't conduct electricity, but your panels will. So you still have to ground. You still have to ground your panels to the ground anyway. So why not use the super purlins? Let's turn the FRPs off, and then ground that. It'd be easy to ground, just at one of these corners. Take your grounds down to the ground there and have your grounding rods. So, and you can always eliminate these outer purlins. It just depends on how many panels you're going to have and the configuration, the ultimate size. He's looking at different sizes, but at some point, and this is my job, is to lead him through the process. Okay, when we were looking at the architectural process, and that's what it is. It's not. People get this confused. Architecture is not art. Okay, if we're lucky, we will have an artistic. We will have art when we're done, but the architecture is the process of getting to that point. Okay, so I'm trying to lead him through, and we have to. At some point, we have to kind of nudge people. And that's what I'm doing right now with this video, is nudging him to make some decisions. Let's see if we have any. God bless you. Oh, thank you. God bless you too. Merry Christmas. So the hard part that a person like I have, and I worked in architecture for 10 years out of my 40 years in the design build industry. And I did that purposely to learn about architecture and the process of creating construction documents and construction drawings. And the thing about this is the engineers don't really like the architectural process, because they want to have exact numbers. They want to develop exact numbers. That's why they're engineers. Okay, that's why we pay them. And in order to do that, you have to give them assumptions. We can't just say we want to put a solar system on the roof. We have to say how we're going to do it and how many panels there are and how much they weigh. So that's where we're going. Where I'm going with this is now I can take this information, if the owner agrees to it, and send it to them and say, look, we're starting to nail down this system, okay, and I can tell them how much this is going to weigh. I know how much each purlin weighs. I know how much each panel weighs, and I can tell them how much weight is going to be on here. If we just keep saying, when I got the proposal from Strongwell, they just gave me an assumption. We're assuming 20 pounds per square foot live load. And I said, well, I think we need to look at this as a dead load. It's just part of the roof system. And then they're like, well, okay, give me something. And I'm like, okay, I understand. The owner's still in the dreaming phase, and you're in the, you're an engineer. You want something. And this is where we are. This is what we got to do. If we can't really move forward until we say, I want these panels. I want this panel right here. You can't say, I want a panel. I want this panel. Okay. And I know he's looking at different options of these panels, but at some point, got to make a decision. And what I'll do is I'll put this on hold in my. I've got like 5 projects I'm working on. I'm going to put this I'm going to send this information off to the engineers, okay, with the weights and materials, all that, and see what they say. And then this will go on hold until we get out of the dreamy phase. When we get out of the dreamy phase, ArtisanTony will kick off again and start working on this project again. So that's some tough love. We gotta get to this point. We gotta get past the dreaming if we want this job to come to fruition. We'll have to get past that. So that's the job of the designer. I'm not a licensed architect, but I am I do have the experience and worked as a project manager for a large architecture firm. And I was actually the person that took the architect's ideas and put it into this type of format where you could get engineering information, cost information, and then all that comes back together. And when you enter the construction documents phase, which we will be doing after this, then we can actually get real prices and you can nail people down that way. So anyway, I think I'm going to end it here unless I have any other questions. I know I didn't have a lot of people viewing this, and that's okay because it was actually for the owner. But I may spend some time making a few assumptions about these shapes, but I was going to get some information back from Strongwell. Yeah, that's what I'll do. I'm going to wait till I get, I was going to actually get them to tell me what their shape sizes are. This is just kind of a pipe dream I had of having these overhangs. I thought it would be cool to have them, but eventually we're probably going to end up with like this beam would be cut off and then slid down and bolted in to the side. The reason the engineers like to do that is because they can take care of certain moments. They can create a situation where some reactions are taken care of when they do that. So this way would require more bracing, I think. And so anyway, there's a lot of engineering that goes into this, and that's the whole purpose of having these schematic drawings sent to different companies to have them analyze it. And the next thing I'm going to do is nail down this company here about the cost and the weight of these super purlins. And I love the concept because what you're doing is you're eliminating you're getting your purlin, you're getting your cake and eating it too. So anyway, to keep from being redundant, I'll cut it off here. And thanks for those who did watch, and we will see you in the next update on this project. Thanks.